world around us is filled with flowering plants. Not just wild plants, but also the food crops on which we depend. Plants which are dependent on pollinators for their survival. Pollinators which have sadly been in decline. According to the UN, most of the 25,000 to 30,000 species of bee are effective pollinators, and together with moths, flies, wasps, beetles and butterflies, they make up the majority of pollinating species. In this project, I'll be developing a Raspberry Pi based sensor system to detect pollinators by audio classification as a potential means of studying local populations for conservation. Clearly, identifying 30,000 species is a bit of a stretch, so I'll be focusing on several bee species found locally to me. Let's take a look now at how we can make this. So first of all, we'll obviously need some kind of microphone to detect the sound of the passing insects. As we're going to be doing this in some field or far away from mains power, we'll need to use solar power. And of course a battery for when it's cloudy or during the night. A power management board will connect it all together, make sure that the battery is charged safely and provide the correct voltage to the rest of the system, including the Raspberry Pi Pico, which is going to be the heart of it, and this is where the audio classification itself is going to be performed. Connected to that, an antenna. This is going to be used to transmit the data from the sensor back to the base station. We're going to wrap this all up in a 3D printed enclosure, a challenge of which is going to be ensuring that it's weathertight, given that I live in the UK. Now this is going to be put amongst our flowering plant where we want to study the pollinators, and we're hopefully going to be using several of these sensors simultaneously. Those sensors will communicate back to the base station, the Raspberry Pi 4, and that will receive the data on the corresponding antenna. I think the best way then to communicate this data is for the Raspberry Pi 4 to host a web server and publish all the sensor data live to a website which, hosted on the Pi, will allow anybody, including hopefully yourselves by the end of this project, to log in yourselves and see the data as it comes through. That's the plan.